Your OpenAPI spec is ready, but how do you ensure AI models only interact with the production-ready endpoints? We'll see exactly how to tag and filter MCP components during server creation, so you can expose only the stable, external-facing parts of your API while keeping internal routes completely hidden. The pattern uses FastMCP's global tagging system to automatically apply metadata that AI clients can respect.
MCP equals FastMCP from OpenAPI. OpenAPI spec equals spec. Client equals client. Tags equals API v2. Production external.
This demonstrates the OpenAPI to MCP bridge pattern, converting REST APIs into AI-callable components. The technique transforms OpenAPI specifications into MCP-compatible tools and resources, creating a standardized interface between traditional APIs and AI models. What makes this distinctive is its ability to preserve API semantics while adapting them to the MCP protocol's requirements. The pattern works through declarative mapping rules that separate API structure from component generation. FastMCP analyzes the OpenAPI spec, applies configurable route mappings, and generates appropriate MCP components, tools for actions, resources for data, while handling authentication, parameter serialization, and type conversion automatically. This declarative approach means you define what components should exist rather than how to create them, keeping the implementation clean and maintainable. This approach matters because it eliminates the need to manually create MCP wrappers for existing APIs. Instead of writing custom tool definitions for every endpoint, you leverage your existing OpenAPI documentation to generate a fully functional MCP server. It's particularly valuable for integrating legacy systems with AI workflows, though the generated components may require refinement for complex APIs where semantic precision is critical. Let's break it down line by line.
MCP equals FastMCP from OpenAPI.
This instantiates FastMCP using its OpenAPI factory method. The factory pattern here handles schema validation and client configuration in one step, eliminating manual setup boilerplate.
OpenAPI spec equals spec.
This passes the OpenAPI specification document that defines all available API endpoints, parameters, and schemas. FastMCP uses this to validate requests and generate type-safe tool interfaces, eliminating runtime schema mismatches.
Client equals client.
This injects the pre-configured HTTP client into FastMCP, ensuring all API calls use the same connection pool and authentication settings. Eliminates redundant client initialization across tools.
Tags equals API v2. Production external.
This applies metadata tags to the FastMCP instance, categorizing it for deployment targeting and access control. The tags API v2 and production route this to the v2 API environment, while external explicitly marks it as accessible outside the internal network. This is the standard tagging pattern for environment-specific tool deployment in FastMCP. This closing parenthesis terminates the FastMCP from OpenAPI constructor call, finalizing the tool creation with the specified OpenAPI spec, client, and tags. Without it, the object instantiation would be incomplete, causing a syntax error. This is standard Python syntax for ending multi-line function calls. Global tagging pattern. FastMCP's global tags propagate metadata across every component, creating an invisible taxonomy that organizes your API without explicit per-endpoint configuration. The tag set you provide during server creation merges with OpenAPI tags rather than replacing them, which can lead to unexpected tag combinations if not planned carefully. Leverage this for environment-specific metadata like production or staging, while keeping functional tags in your OpenAPI spec.
The tag that labels everything becomes the label that disappears.